Over the last few episodes, we've explored the physics of comfort, looking at air temperature, radiant temperature, and how the two come together as operative temperature. But thermal comfort isn't just about physics, it's also about people. What we wear, how active we are, and how our bodies produce heat. Two people can sit in the exact same conditions and feel completely different. One might say the room feels perfect, the other might reach for a blanket. In this video, we're going to look at the personal factors behind thermal comfort, clothing, metabolic rate, and why your subjective experience can differ from someone else's even when the environment is identical. Let's start with clothing. In building science, clothing insulation is measured in kilo units, where 1 kilo is equal to 0.155 square meters Kelvin per watt. 0 kilo corresponds to being completely naked. 1 kilo typically corresponds to a person wearing a business suit, or to get more technical, and hang on, since this might be a bit much, it corresponds to the amount of clothing needed to keep an average person comfortable while at rest in a room at 21 degrees Celsius with air movement of around 0.1 meters per second and humidity levels of less than 50%. Heavier outfits, such as winter jackets, scarves, etc., can go up to 2 or 3 kilo. Clothing acts as insulation, slowing the heat flow from your body to the environment. The more insulation you wear, the warmer you feel for the same operative temperature. This is why an office designed around a standard 1 kilo might feel chilly if people show up in summer clothes, or too warm if they're bundled up after commuting in cold weather. Clothing can easily shift comfort by several degrees, without changing the room at all. Next is metabolic rate, which is measured in met units, where 1 met is equal to 58 watts per square meters. 1 met corresponds to the metabolic rate of a seated and relaxed person. As activity increases, metabolic rate rises. Light walking is around 2 met. Housekeeping might be 2.5 to 3 met. Intense physical activity can go well above 4 or 5 met. And one of the most intense activities is running with around 9.5 met. The higher your metabolic rate, the more heat your body generates. That means the same room can feel cool when you're resting and uncomfortably hot when you're active. This is why gyms feel warmer than offices, even when the thermostat reads the same or even a bit less. It's not the building, it's the people inside it producing more heat. To calculate the amount of watts a person produces, you can take the average surface area of the human body, also known as the Dubois area, which is approximately 1.8 square meters, and multiply this by the watts per square meters value from this table. For a person driving a car, this would give us 80 watts per square meters times 1.8 square meters, giving us 144 watts. When we talk about comfort, the building isn't acting alone. Your body is constantly giving off heat through your skin, through your breath, and through your clothing. The amount of heat you produce and the amount you lose determine how warm or cool you feel. Environmental factors like mean radiant temperature and air temperature define the conditions, but personal factors define your response to those conditions. This is why comfort standards such as ASHRAE 55 and ISO 7730 include both. Your building can be perfectly designed, but if people are wearing heavy coats indoors or engaging in high intensity activity, their thermal comfort will shift. Understanding personal factors helps designers and engineers create spaces that feel comfortable across a range of real-life conditions. For example, offices with flexible dress codes may need wider comfort ranges. Buildings where occupants move a lot, like retail, hospitality, or warehouses, need different temperature strategies than quiet work environments. Spaces with seasonal clothing changes may require dynamic controls. And buildings with steady, predictable occupant activity, such as gyms, can be tuned more precisely. Personal factors also matter for energy performance. A space where people wear appropriate seasonal clothing can operate comfortably at lower winter temperatures or slightly higher summer temperatures, saving energy without compromising comfort. What makes thermal comfort challenging is that it's not just physics. It's personal, it's behavioral, and it's cultural. Comfort expectations vary by region, by lifestyle, even by gender and age. Someone used to cool indoor temperatures might feel warm in conditions another person finds perfect. Someone wearing breathable fabrics will feel entirely different from someone wearing thick layers. This complexity is why comfort models don't aim for perfection, they aim for predictability. They help us design spaces that work well for most people most of the time, while giving occupants the flexibility to adapt. Stay informed, stay inspired. TimberTalk.